Here we have another example of instruction that is converted from assembly to machine language, and we can see some differences in that. So we have the divide or division instruction, and that basically acts very similarly to the multi instruction. So to the same multiplication that we saw in the previous slides. So when you have this, you're giving the two registers, or you're specifying two registers that there is a division being performed here, and we are using at the same time the low and high registers to hold the answer of this division. So this is an integer division, and the low register is going to hold the quotient basically. So if, for example, this was 10 divided by 3, you have 3 times 3 is 9, and you have one reminder. So the low register would be 3 here. The high register would be the reminder of this division if you are doing an integer division. And in our example of 10 dividing by 3, the reminder would be 1. So the high register would basically have the number 1 stored in it. So here we are seeing that if you have a basic divide that we've seen this before, here we are dividing this at 22 by 21, and then the answer is being saved in 23. So when it's converted to machine language, we actually have this division with two registers only, and we are getting the answer from the low registers, which is actually holding the division result. If you are doing a reminder operation, it's the same idea. So you are getting the reminder of the division of the register 22 by register 21, and you are saving the result in 23. So it's the same operation, so the division with two registers, and this time you are taking the result from the high register, which has the result of this reminder. And again, we see here that the conversion between assembly and machine language is a bit different. So we are not always getting the exact same registers. So also one more thing I want to note, that here all of these are still R format. And the fact that it has two registers, it's just one of them is not set in the bit pattern that we're gonna see.